In this video we're going to look at 2021 paper 2 question 4, and we're talking about trigonometry here. Now the very first part of the question is just one of our proofs that we studied on the course, so let me just add in, let's review what we've already studied earlier in the year.
Okay, the next proof is a really straightforward one. The next proof we need to look at is to prove that cos 2a is equal to cos squared a minus sine squared a. Notice that this is halfway down page 14 in your maths tables, which means we can use anything prior to it in order to prove it. The rule that we're going to use, the formula we're going to use to prove that cos 2a is equal to cos squared a minus sine squared a, is the rule for the cos of a plus b. On the top of page 14, it tells me that cos a plus b is equal to cos a cos b minus sine a sine b. In other words, proof number 5. This is proof number 6, so we're going to use the previous one in order to show it's true. We're going to start off with cos 2a, and I want to manipulate this so that it becomes cos squared a minus sine squared a. The first thing we're going to do is split up 2a. 2 times a is obviously the same as 1 times a plus 1 times a. So cos 2a is the same as cos a plus a. So now I have the cos of an angle plus another angle. And I know from proof number 5 that the cos of a plus b is cos a cos b minus sine a sine b. I'm going to sub into that. The only difference is that in this case, a is a, but b is also a. Both of the angles are a. So cos a cos b will become cos a cos a. Minus sine a sine b will become minus sine a sine a. Now obviously cos a and cos a are the same thing. So when I multiply them by each other, I'll get cos squared a. Sine a and sine a are the same thing. So I multiply them by each other, I'll get sine squared a. So I started off with cos 2a, and I'm after proving that that is obviously equal to cos squared a minus sine squared a. So that proof number 6, is quite straightforward.
In A part 2, we're told that the sine of theta over 2 is equal to 1 over root 5. And we're asked to use the formula cos 2a equals cos squared a minus sine squared a to find cos theta. Now, what you should recognize first of all, let's consider the angles first of all. We know the sine of theta over 2, and we're looking for the cos of theta. Obviously the sine of the angle I have, well, this angle is half as big as the theta. So you have to recognize that. Now we've been told that we need to use this formula. You should recognize there's a similar relationship in this formula. The angle on the left is a 2a, the angle on the right is an a. Or in other words, the angles on the right hand side are half as big as this angle. So in this context, you should realize that the angle we're looking for, instead of looking for cos 2a, we're looking for the cos of theta. That's what we're looking for. And in order to get the cos of theta, we're going to use cos squared, and half of 2a is a, half of theta is theta over 2. So all I'm doing is replacing the a with theta over 2. You should recognize that what I've written, the second line here, it's the exact same as the first line, just that instead of an a, we're using theta over 2. And then obviously if I multiply a by 2, I get 2a. If I multiply theta over 2 by 2, I get theta. So this gives me a formula that's going to allow me to get the cos of theta. And it's really it's straightforward here. I can see I already have the sine of theta over 2. I know it's 1 over root 5. If I just square that, that's the second term on the right hand side dealt with. But I do have a question mark at the moment over cos theta over 2. I don't know anything about cos theta over 2 for the moment. So the next couple of lines we need to try and figure out what this is. Once we know what cos theta over 2 is, we're going to come back to this line, we're going to sub in, and if I get cos squared theta over 2 minus sine squared theta over 2, I'll be left with the cos of theta. So that's the goal. And it's relatively straightforward for us to get the cos of theta over 2. Whenever you have the sine, cos, or tan of an angle, if I know the sine of an angle, I can get the cos of that angle or the tan of the angle. If I know the cos of the angle, I can get the sine or the tan. It's easy enough as long as I sketch a right angle triangle. Think of what you did in junior cert trigonometry. I'm just sketching myself a random right angle triangle here. And I'm going to label one of the angles as theta over 2. Remember what you studied in 3rd year. In junior cert we learned that the sine of an angle in a right angle triangle is the opposite over the hypotenuse. So I can say that if this angle, theta over 2, existed in a right angle triangle, the opposite would be 1 and the hypotenuse is root 5. The opposite is 1 and the hypotenuse is root 5. Notice here that if you just look at this diagram, there's an angle, the opposite is 1, the hypotenuse is root 5. So I could say that in this scenario, the sine of the angle is equal to 1 over root 5. This diagram simply describe, like this equation and this diagram, they mean the same thing. And now I know two sides in a right angle triangle, so I can use Pythagoras theorem to get the third side. So that's all I'm going to do now. I just say, right, 1 squared plus x squared is equal to the square root of 5 to be squared. That's not a squared. So obviously that's just the square root of 5 to the power of 2. Now I have one equation and one unknown. I'm going to be able to work out my x. 1 squared is 1, x squared I can't do anything with it, and the right hand side I just get 5. If I subtract 1 from both sides, I get x squared equals 4, and I end up with x is equal to 2. Or in other words, I've worked out that if the opposite is 1 and the hypotenuse is the square root of 5, then the adjacent is simply 2. Now that I know the adjacent, I can easily enough get the cos of theta over 2. If I want the cos of theta over 2, we also learned at junior cert that that is simply the adjacent over the hypotenuse. In this case, the adjacent is 2 and the hypotenuse is the square root of 5. Now think back to what I said a moment ago. All we need is cos of theta over 2 and sine of theta over 2, and we can answer this question. So we've already worked out that cos theta is equivalent to cos squared theta over 2 minus sine squared theta over 2. We can sub in for cos theta over 2, we can sub in for sine theta over 2, and when you plug this into your calculator, your final answer works out that cos theta is equal to 3 over 5. In part B of this question, we're told that the tan of b plus 150 is equal to minus root 3. And we're asked to find the possible values of b between 0 and 360 degrees. Now there's two different ways of doing this question, and I think it's important that you're capable of doing it by both methods. I'm going to use the unit circle to solve this one, and when you're finished, when you've watched my solution, I encourage you to go to page 14 in your maths tables, try and use the formula tan A plus B in order to solve it. I think the formula for tan A plus B, it's going to be longer, but probably easier. The way that I'm going to use the unit circle, there's a little catch in it that a lot of students might have missed if they tried to do this in the exam. So the first thing you have to recognize, if we're using the unit circle, obviously it's strange because there's a b plus 150. We're going to first of all solve for b plus 150, and then in our very last line we'll worry about the 150. So you should recognize we've done something similar to this in our study of trigonometry. If you ever had an angle like 2a or 3a or 4a, or if there was a coefficient in front of the angle, the first thing we always did was change the domain. That's the same thing we're going to have to do here. The question is asking me to get b between 0 and 360 degrees. So what I have to ask myself is, well then what's the domain for b plus 150? b plus 150, obviously I have to increase the lower end by 150 and I have to increase the upper end by 150. If I want b between 0 and 360, that means that I want b plus 150 between 150 and 510. All I did was add 150 degrees to either end of the domain. And now it's just a basic unit circle question. The next thing we're going to look at is how to get our reference angle. So go to page 13 in your maths tables, and if you look at that table on the bottom, you go to tan and work your way across to root 3, the corresponding angle is 60 degrees. So in this case our reference angle is simply going to be 60 degrees. Obviously we don't use radians here because the domain was given in degrees, so we're going to use degrees. The next thing I need to ask myself is what quadrants are relevant. And now the minus in front of the root 3 is important. The quadrants in which the tan of an angle is negative is S and C. Or in other words, the second quadrant and the fourth quadrant. To get a value in the second quadrant, we always think of it as we've done half a revolution and we're going back into our second quadrant. Or in other words, it's 180 minus 60. In this case, that gives me 120 degrees. Now you should recognize something here. That's actually too low. That's not in my domain. The minimum value I want is 150. So that one is actually not actually relevant. We didn't need to even incorporate it. The next one that I need to get is in the fourth quadrant. In the fourth quadrant, we always think of it as we've done a full revolution and we're going back into our fourth quadrant. So in this case, it's going to be 360 degrees minus 60, which gives me 300 degrees. Now, the domain I'm going for is between 150 and 510. So let's keep going. Let's get the next answer and investigate, is it within the domain? So if you do one full revolution, you get a value in the second quadrant and then the fourth quadrant, and then you're starting off again at 360 degrees. Let's continue on and see what the next answer would be. The second time we're going around the quadrant, the circle, to get a value in the second quadrant, 360 plus 180 is 540. So we're at 540 minus our reference angle. 540 minus 60 gives me 480 degrees. And happy days, that one's within our domain. I just want to make sure it's not bigger than 510, so that one's okay. So, and we don't go any further, because if you wanted to get a value in the fourth quadrant next time, you're at 720, and obviously the value we're going to get is far bigger than 510. So the only two solutions where the tan of an angle is equal to minus root 3 within the domain from 150 to 510 is 300 degrees and 480 degrees. But now you should recognize that we haven't found b. We have found two possible values for b plus 150 degrees. b plus 150 degrees could be 300 or it could be 480. And obviously we're not trying to find b plus 150 degrees, we're simply looking for b. So we subtract 150 from both sides. And in that case, my answers will become 300 degrees, 300 minus 150, is 150, 480 minus 150 gives me 330 degrees. So those are the two possible values for b. Now that one is the shorter method. I think it's probably trickier though, because of it's very tricky there with the domain. Once you've seen this now, you know your answers, go back, go to page 14 in your maths tables, try and use the formula for tan A plus B, and essentially you're just trying to solve it, and you should get the same two answers.